Hello students, welcome to Physics for Everyone classes. This is your Satish. So in this section, we can see about the chapter Alternating Current. This is a lecture 1 from this chapter, and here we are going to complete what is alternating current, the source, the principle which is involved, and the expression for the alternating current, what kind of current that we are getting in the houses, how it is different with the direct current, all these things that we can see in this slide. Let us see. The main source for the alternating current is the AC generator, and the principle which is involved is electromagnetic induction. There in a certain magnetic field, uniform magnetic field, there we kept a rectangular coil. If this coil is rotating with an angular velocity omega, the flux linked with the coil continuously changes. According to that, in that coil, there it induces an EMF, which is the varying voltage. With that, you will get the alternating current. So the main source of alternating current is the AC generator, and the principle involved is electromagnetic induction, Faraday's second law. You can see E is equal to minus d by dt of phi, where phi is the flux linked with the coil. If the flux is constant, induced EMF is 0. So whenever there is a change in flux, either increases or decreases, always an EMF is induced in the coil that gives the alternating current. And minus d by dt of general formula for the flux is BA cos theta, where theta or the phi is the angle between, there can write the theta is the angle between the magnetic field intensity and the areal vector, where n is the total number of turns. And if you differentiate this one with respect to time, you will get the result BAN omega sin omega t, because BAN is constant, it will come out of differentiation, and derivative of cos theta, which is minus sin theta, and negative will be get cancelled out. We need to differentiate theta as omega t, right? Theta is equal to how much? Omega t. If you differentiate omega t, you will get omega outside. All together, you will get BAN omega into sin omega t. And this term, which is very important, it is also called the maximum value of voltage. How much it is? E naught is equal to ban omega, BAN omega. So E is equal to E naught sin omega t is the alternating voltage, the expression for the alternating voltage. E naught is the peak value that we can get, BAN omega, B is the magnetic field induction, A, area of cross section of the coil, N, the total number of turns, omega is the angular velocity. If you take these things, you will get the peak value, or it is also called as the amplitude of the EMF of an alternating source. This is the expression that we need here. So let us see, if t is equal to 0, sin 0 comes as 0. At t is equal to 0, induced EMF, or we are writing it as voltage. Generally, it is called as EMF as the voltage. So at t is equal to 0, voltage is how much? Alternating voltage is 0, or the current is 0. At t is equal to t by 4, there you can see it has got the peak value. Induced EMF or the voltage or the current has got its maximum value, that is the peak value or the amplitude of the current, I naught. And again at t is equal to t by 2, the current comes as how much? 0. And more importantly, the current is changing its direction. From 0 to t by 2, the current is positive. From t by 2 to t, the current is negative, which means the current is going to change its direction for every half cycle. And again at t is equal to 3t by 4, the current has got its maximum value in the reverse direction. It is denoted by minus I naught. And at t is equal to t, So after one cycle, again the current comes as 0. So in this manner, this pulse, this alternating current is being produced and whose value is changing with respect to time and it satisfies the equation. So I is equal to I naught into sine omega t. This is the reason this wave is also called as sinusoidal alternating current. This is one of the form of alternating current. We have got a different forms like square wave or a sawtooth wave, but these things we can deal in the next sections. So we are mostly concentrating on the sinusoidal pulses, how to find the average value or the R.M.S value. All these things are really important for the competitive examinations. So far what we have seen in this slide, the source of alternating current is the AC generator. The principle involved is the electromagnetic induction, which is nothing but Faraday's second law. With that we got the result or the expression for the alternating voltage or the alternating current. How much? E is equal to E naught sine omega t, where E naught is BA and omega, or the alternating current is defined by I is equal to I naught sine omega t. So with respect to time value, how the time value changes accordingly, there you will get the alternating current is also going to, we are going to find the average current for the complete cycle. How much the value is. For any physical quantity to find its average value, we have got the expression, the average current I, such a kind of bracket if you have taken, it indicates the average value. Average current is equal to integral of 0 to t for the complete cycle. So I into dt divided by integral of 0 to t dt. So this is the most general expression to find the average value of any physical quantity. Here the physical quantity is the current. And there we know for the alternating current, the general expression is how much it is. I is equal to I naught into sine omega t. Now place this equation here. You will get integral from 0 to t. I is how much? I naught sine omega t into dt divided by integral of dt is t. With the limits 0 to t, you will get time period t, and that is equal to I naught is the peak value which is constant. You can take out of integration I naught. Integration of sine omega t is minus cos omega t. You will get minus cos omega t. We need to differentiate this function omega t. So omega t differentiation is omega. We should write in the denominator divided by omega with the limits 0 to capital T. By t is there. You can write outside I naught by t in this way. And what is omega? We can write it as 2 pi by t. So that is equal to, so I naught by t, omega is 2 pi by capital T into, and if you take negative outside there and substitute the limits correspondingly, cos omega is 2 pi by capital T into small t how much? Capital T minus cos 2 pi by capital T into 0. Lower limit is 0. And t get cancelled here. Cos 2 pi, cos 360, nothing but cos 0, the value is 1. And here cos 0, again you will get the 1. So 1 minus 1 is 0. You will get the entire result is how much? 0. So for the complete cycle, for 0 to t, the average value of current we got it as 0 with the integration. So without integration, we need to remember the average value of sine omega t. If you take the average value for the complete cycle, always the expression, the value is equal to how much? 0. So if you remember this one, the average value of sine omega t for the complete cycle is how much? 0. Similarly, the average value of cos omega t also comes as 0. So please remember these two results But to find the average value for the complete cycle, either if it is a sine wave or a cos wave, for the complete cycle, the result is how much? Zero. Average current for the complete cycle is how much? We got zero. Now, we are trying to find the average value for the half cycle, how much the result is. Let us see. So in this slide, we are going to find the average current for the half cycle, which means from 0 to t by 2. How much is the value? So for this one, again, we need to use the same average value for the half cycle is equal to integral of 0 to t by 2 integral of I dt divided by integral of 0 to t by 2 dt. So which is equal to, so what is I value? I naught sine omega t. There you can write I naught outside integration of so sine omega t dt. Only the limits are changed 0 to t by 2, and here you will get integral of dt is t. The limits is t by 2. It comes as t by 2. So it is nothing but 2 I naught by t. So integral of 0 to t by 2 into sine omega t dt. That is equal to 2 I naught by t. So what is integral of sine omega t, which is minus cos omega t. So minus cos omega t divided by omega for the limits 0 to t by 2. That is equal to 2 I naught by t. Omega is 2 pi by t. 2 pi by t. T get cancelled out, and 2 also get cancelled out. And you can write here negative sign outside. And cos of 2 pi by t into, where small t is how much? T by 2. Earlier it is t, now it comes as t by 2. Minus cos, directly you can write it as 0. That is equal to minus I naught divided by pi into, there you can see t get cancelled, 2 get cancelled. Cos 180 is minus 1, cos 0 is 1. Minus 1 is, you will get minus 2, which is equal to 2 I naught divided by p. So the average value of current for the half cycle, we got it as 2 I naught divided by pi. And remember, without doing integration, then we got the result. The average value of sine omega t for the half cycle, and take it as 2 divided by pi. And if you remember this one, no need to do the integration. It always be the bigger process regarding the competitive examination point of view. So avoiding all such things, just if you remember, the average value of sine omega t for the complete cycle is 0. The average value of sine omega t for the half cycle is how much? 2 pi by 2 divided by pi. It is 2 divided by pi. So by keeping these results in your mind, so within the seconds we can complete the questions related to the average value of the current of the voltage. And here you can see the term integral of I into dt. This is also called as the area under the graph between the current and time. Area under the curve, area under the graph between the current and the time, which is nothing but integral of I dt. If you see for the complete cycle, so the positive cycle, how much it covers the area, let it be taken A. The same area has been covered by the negative cycle also. It has been taken as minus A. When you add these two, you will get plus A minus A. The net effective area for the complete cycle is how much? 0. That we are seeing in the first case. For the complete cycle, average current is how much? 0. Here, by omitting the negative cycle, by considering only the half cycle, we got the result how much it is for 2 I naught divided by pi. Or we can say the area of this curve, the area of the sine curve for 0 to t by 2, the result is how much? 2 I naught divided by pi. Or at least you can remember the average value of sine omega t for the half cycle is equal to how much? This is very important, 2 by pi. Let us see one example related to the average current. How to find the average current. An example is the current is given as 5 sine 314 into t, and we need to find few parameters. One is the peak value of the current, second is the frequency, the third is average current for the half cycle. Half cycle in the sense either we can take 0 to t by 2 or t by 2 to t, or else the average current for t by 4 to 3t by 4. This is also the half cycle, and initially we need to find the peak value. Let us see and compare this equation with the standard equation, which is I is equal to I naught sine omega t. By comparing these two, directly we can write the peak value of the current is 5. So therefore, I naught is equal to 5 ampere. The second one is the frequency. So what is 314? It is the angular frequency. We can write omega is equal to 2 pi f, which is equal to 340. And with this we can write frequency is equal to 314 divided by 2 into pi is 3.14. You can write it as 3.14. And these two will get cancelled how many times? 100 times. 100 by 2, which is equal to 50 hertz. In India, the alternating current which has been created by the AC generator, which is set with a frequency of 50 hertz, which is a standard value. And next one is the average current for the half cycle. We have got the formula for the half cycle. Average current for the half cycle, that is from 0 to t by 2 positive cycle, which is equal to 2 I naught divided by pi, and that is equal to 2 by pi 3.14 into the peak value is 5, nothing but 10 divided by 3.14. Or else you can write, we know already 2 by pi, which is the value is 0.63. 63% of the peak value that you will get the average value. So you can write it as 2 by 3.14 is 0.63 into 5. If you multiply, you will get 5 3 is a 15, 6 5 is a 30. You will get 31. So 2 decimals, you can write here 3.15. So 3.15 ampere. 0.63 into 5, you multiply it, you will get 3.14 ampere. And the same way, if you find the average value for the half cycle, that is also for the negative cycle, t by 2 to 3, which is the negative cycle, which is equal to minus of 2 I naught divided by pi. The same result you will get with negative sign, minus 3.15 ampere. You see, this is 0. Here it is, this one is t by 4, this is t, and this is 3t by 4, and it comes as t. And we are finding from t by 2 to how much? The second one, t. From t by 2, where it is, this one is. From here to here, negative half cycle. How much the value you will get for the positive half cycle? The same value you will get. Only the thing is that the current direction is reversed. With that, you will get the negative sign. And the last one is average current. This is also for the half cycle, but we are choosing not entirely positive, not entirely negative. Some part is positive, some part is negative. There you can see, this is the complete cycle, and we are choosing the time from t by 4 to this is 3t by 4. So from t by 4 to t by 2, the cycle is positive, and this area you can take it as, suppose A. From t by 2 to 3t by 4, and you got this is negative area, should be taken as minus A. And for this time interval, this is also half cycle. In the half cycle, 1/4 cycle is on the positive side, 1/4 cycle is on the negative side. So net effective area for this half cycle is equal to how much? 0. So the average current For the half cycle which is from T by 4 to 3T by 4, the result is how much? 0. So it is not necessary the alternating current should have the value 2 pi by 2 I naught by pi for the half cycle. It is important which time interval we are choosing. Completely if you are choosing positive cycle, you will get the result 2 I naught by pi. Completely if it is negative cycle, you will get minus 2 I naught by pi. If it is 1/4 is positive, 1/4 is negative, you will get the average value for the half cycle is how much? Is 0 again. Example, it is a composition of two alternating currents. Complex equation it is given. I is equal to 4 sin omega t plus 3 cos omega t. For this, we need to find the average current for the full cycle and for the half cycle. Let us see for the full cycle. So average current for the full cycle, which is equal to, let us take 4 as 4 only. For the first alternating current, 4 is the peak value. 4 into average value of sin omega t plus, for the second alternating current, the peak value is 3. You write 3 directly. And the average value of cos omega t, which is equal to 4. As I mentioned earlier, the average value for the sin omega t for the full cycle is how much? 0. So 4 into 0 plus 3 into the average value of cos omega t for the full cycle is also 0. And you will get the result is 0. So take this result. The average value of sin omega t, the average value of cos omega t for the full cycle is always equal to how much? 0. It is always 0. And the second case is what is the average value for the half cycle? Let us see. Is it okay? For the full cycle, the answer we got how much? Average value 0. For to find the half cycle, so I average for half cycle is equal to, write the peak value 4 into the average value of sin omega t for the half cycle plus 3 into average value of cos omega t for the half cycle, which is equal to 4 into sin omega t average value for the half cycle. We know how much it is. It is 2 by pi. 2 divided by pi plus 3 into average value of cos omega t, which is equal to 0. It depends on the time interval. Suppose if you have taken the cos function, the graph is been like this. For the half cycle, this is 0 and this one is t by 4 and this is 3t by 4 and this one is you can take, sorry, this is t by 2 and here it is 3t by 4 and this is t. For half cycle means 1/4 you will get positive, 1/4 you will get negative, and whose average value for the half cycle, how much you got? 0, and which is equal to 8 divided by pi. So you got the second result, average current for the half cycle from 0 to t by 2, which is equal to how much? 8 divided by pi. And the average value of sin omega t for half cycle from 0 to t by 2, how much the result? 2 divided by pi. Remember this one, 2 by pi. And the average value of cos omega t, average value of cos omega t for the half cycle from 0 to t by 2, which is equal to how much? 0. So if you know these results, we can simplify these equations without doing any integration. What is the average current? How to find the average current for the half cycle, for the full cycle, or for any given interval of time? So in this slide, we can see to find the R.M.S. current, root mean square current. So this is most important than the average current. Let us see. Any instrument which is going to measure the kind of current which is nothing but the R.M.S., root mean square value. Let us see how to calibrate it. So as the name itself says, root mean square. We start with square and take the mean of all the values and finally root of it. We started with I square. What expression we have got I naught sine omega t. We to square of it. After that, take the average of that and finally find the square root of that value. So before finding RMS directly, initially we are finding the mean square value. I square with this bracket, which is called as the mean square value, which is equal to integration from 0 to t. This is for the complete cycle, 0 to t. So I square dt divided by integral of 0 to t dt, which is equal to integral of 0 to t. What is I value? I is I naught sine omega t. If you have taken I naught square will come outside, I naught square, and you will get here sine square omega t dt, and whole divided by integral of dt is t. You will get capital T. I am writing here capital T. You can see I naught square divided by t integration sine square omega t dt, and this is equal to I naught square divided by t, and we can write this sine square omega t dt as 0 to t 1 minus cos 2 theta divided by 2. So 1 minus cos 2 theta 2 into omega t divided by 2 into dt. That is equal to I naught square by t, and 2 you can take outside, and then we can write integration from 0 to t. The first term comes as dt minus integration of 0 to t. The second term is cos 2 omega t dt, and that is equal to I naught square divided by 2t into integral of dt is t. Limits is t minus 0. You will get here t minus. So what is integral of cos 2 omega t? It comes as sine 2 omega t divided by 2 omega. So you can write here sine 2 omega t divided by 2 omega between the limits 0 to capital T. And interestingly, you will get, let us see, if you take omega as 2 pi by capital T, small t as t, and t get cancelled out, 3 into 2 pi you will get 4 pi, sine 4 pi, sine 0 0, sine 2 pi 0, sine 4 pi, sine n pi is 0. The lower limit again you will get sine 0 is 0. So all together this entire expression comes as 0 by substituting the limits for the complete cycle. No need to take the second part. And finally, and this t get cancelled, you will get I naught square divided by 2. So the mean square value for the alternating current for the complete cycle, we got how much? I naught square by 2. But we need root mean square value, RMS value. So IRMS, root mean square value, which is equal to, we need to take the root of this one, under root, how much we got? I naught square divided by 2. That is equal to I naught divided by root 2. So RMS current for the complete cycle, how much we got? I naught divided by root 2. And 1 by root 2, we know 1 by 1.414 into I naught. And this is nothing but 0.707 into maximum current. In the case of average current or the mean current for the half cycle, we got the expression how much for the half cycle is 0.63 of I naught, or 63% of the maximum current in the case of average value. Here in the case of RMS value, we got the result how much? IRMS is equal to 70.70%, 70.7% of maximum current. So comparing these two values, and this is giving effectively more value than the average value. So because it is called as RMS current, is also called as effective value of the alternating current. RMS current or effective value of the alternating current is called as the root mean square alternating current. In this way we can find the RMS value. And we can see how to find the RMS value for the given expression. So before that, we need to take one important result from the derivation of RMS current. Through the process, we have got the average value of sine square omega t. The average value of sine square omega t, or the average value of cos square omega t for the complete cycle, which is equal to how much? 1 by 2. Because we got mean square value, how much we got in the expression? I naught square divided by 2. We got I naught square by 2. So the mean of sine square omega t value or the mean of cos square omega t value, always how much it is? 1 by 2. If we know this result, we can easily solve these kind of complicated questions. Let us see. So the mean of sine square omega t or the average of cos square omega t value, always how much it is? 1 by 2. Please remember this result. So let us start. For to find IRMS, so we need to find first mean square value, which is nothing but sine square. You take the average of it, the mean square. So first you square this one and take the average of it. So first you square the given expression, only square it. No need to take the mean, later you can take. So square the given expression. I square is equal to a plus b whole square. You can write it as a square plus b square cos square omega t plus 2ab. So 2 into a into b into cos omega t. And take the average of this one, I square with the average, which is equal to a square is constant, average of it is itself comes as a square. So you write it as a square plus b square is constant into average of cos square omega t plus 2 into a into b into average of cos omega t. That is equal to a square comes as a square plus b square into what is the average of cos square omega t, which I got it as 1 by 2 right here, into 1 by 2 plus average of cos omega t or sin omega t is always how much it is? 0. So you won't get any further term. So you got it as how much? A square plus b square divided by 2. For to find the RMS value, we need to take root of this one. So IRMS is equal to under root the square of the mean values, which is equal to how much you got? Under root a square plus b square divided by 2. So we have got the generalized equation for this kind of superposition of two alternating currents. Actually, one is direct current. Here A is a constant value, which is a direct current, is combined with the alternating current. It is a mixture of direct current and alternating current. We have got the result IRMS is equal to under root a square plus b square divided by 2. And let us see one more example here. Is a composition of two alternating currents. Let us see once. Suppose I is equal to a cos omega t plus b into sin omega t. Now you can see the first term is the one alternating current and second is the second alternating current. If these two are superimposed, then what is the RMS value? The resultant RMS is equal to how much? Same process. First you need to take the square of the expression, I square, square this one. So a square cos square omega t, that means whole term comes as a, first term square plus second term square is b square sin square omega t plus 2ab. So 2 into a into b into cos omega t into sin omega t. So it is been like this entire term is first term, this entire term is second term. So a plus b whole square is a square plus b square plus 2a. And take the average of this one. So a square into mean of cos square omega t plus b square into mean of sin square omega t plus 2 into a into b into mean of cos omega t into mean of sin omega t. So that is equal to a square. What is the mean of cos square omega t, which is 1 by 2? So a square by 2 plus b square, again mean of sin square omega t is 1 by 2, b square by 2. And mean of cos omega t or mean of sin omega t is always 0. And even the third term is 0. That is equal to a square plus b square divided by 2. If you take the RMS value, which is equal to under root, how much? I square with mean, that is equal to under root a square plus b square divided by 2. So the question has got two alternating currents which are being superimposed for to find the effective alternating current or the RMS value of alternating current. We got the expression under root a square plus b square divided by 2. So these two examples which are very important for the NEET as well as the JEE point of view.